私聊了之后你会怎么做？有约到吗？私聊了之后怎么做？有约到。
好了，我设定好了啊，然后我们现在开始直播了啊。
好，Hi, Kawai. I see you. Okay. Okay. I see you. Let's get started. Okay. See. Let's get started. Okay. All right. Hello, everybody. I have opened up the stream. Okay. I see that there are lots and lots of students coming in. All right. Thank you so much for being. Thank you so much for being super punctual. Okay. And yeah, we will start our live stream in 2 minutes. Okay, by the way, if you are seeing this live stream now and you haven't registered for P2 TASMO, all right, please make sure to do so, okay, by scanning the QR code below. Okay, it will be held on this Saturday, at September 13th from 9 a.m. to 10:30 a.m. Okay, we have 3 locations available and the difficulty level is around P2 to P3 TASMO. Okay, today we are going through sample paper 2. Okay, I have 3 more papers coming up for everyone's practice. So yeah, hopefully they are all useful materials for you all. All right, in 2 minutes, we will start off our live stream on the sample paper 2 analysis. All right. Hello. Okay, I see a lot of kids saying hi to me. Hi, hi, hi. Hi. All right, so again, right, as we are 1 minute left into the live before the live stream starts, okay, just a quick reminder, if you haven't registered for TASMO, okay, please do so by scanning the QR code on the screen. Okay, we have 3 locations available, and yeah, so do check them out. By the way, if you are here in the chat, okay, would you mind sharing with me, right, which question number is the hardest question? Which question do you think is the hardest in this paper? Okay, if you remember the question number or you remember what the topic is about, okay, feel free to let me know. Okay, I will see, does it match what I'm going to talk about today? Let me. Oh, yeah. Okay. Joseph said question 24. Yes, I'll be going through that question. Okay. It is a bit high tech, but no worries. Okay. I will use some more easy methods, okay, to help you do your calculations. Anyway, now that it's already 5:30 p.m., okay, welcome everybody to our sample paper 2 analysis for P2 TASMO. Okay, so this week I have received more kids submission, right until the last minute. I still see there's some submissions. Okay, as you can see here, 54 kids have submitted this week, which is way more. Oh, 55. Okay, I just received another submission. Thank you so much, okay, for your active participation. I will reach out to you and talk more about your performance later, okay, for those who have just submitted. As for this paper, okay, I have collated the top few challenging questions, okay, both from section A and section B. As you can see, there are two very evil problems, right? My question 20 and question 24. All these questions have a lower than 10% accuracy rate, so it means it's pretty difficult, and I'll be going through them in detail, okay? So for today, other than question 20 and 24, I'll be going through 2 questions in section A and 5 questions in section B in total. Okay, if time permits, I will be having more questions ready as well. Okay, so without further ado, let's get started for the section A problem. Okay, so this is a section A question 8, okay, where we talked about 3D coloring problems. Okay, however, this is just a warm-up, right? The actual question will be in the next slide, okay? So 3D coloring problems is usually about having some cubes, like some small cubes. You are gluing them together and then you paint the entire structure, okay? And then you are going to count the number of painted faces on all these small cubes, right? How do you count the number of painted faces, right? We usually consider 3 perspectives, or in other words, 3 directions, right? Directions. Okay, 3 directions. What are these directions, right? If you remember your 3 perspective diagram, you should know about front and back, left and right, top and bottom, right? Your front view, your side view, and your top view. So these are the 3 positions, right, that you should look for. So let's count one by one and see what's going on. Okay, front and back, right? We have 1, 2, 3, right? When you look from the front towards the figure, you can see 1, 2, 3 faces. They are exposed to you, right? So when they are exposed to you, you can paint on these faces, right? So on the front, you can see 3 faces. Now, what about back? Now, actually, if you see some cubes arranged together, the front and the back will have the same number of painted faces, right? The front and the back, 1, 2, and 3 hidden here, right? There's another 3 painted faces. So front and back altogether, I will have 3 plus 3 equals to 6 painted faces. Okay, what about left and right? Now, I can also stand from the side and look at the cubes and see how many faces are exposed. Now, if teacher Yong Lam is looking from the side, right, just now teacher is looking from the front. Now I'm looking from the side, then how many faces can I see from the side? I will be able to see 1, 2, 3, 4. Right, 4 faces. For some reason, my pen isn't working. Okay, so we have 1, 2, 3, 4. Oh, sorry for the technical issue. 1, 2, 3. Ooh. 4, right? 4 faces. So I have 4 faces when looking sideways from the right. So likewise, from the left, you will also see the same number of faces as well. So 4 plus 4 is equal to 8. Okay, so there are 8 faces, 4 from the left, 4 from the right. So when you can figure out, right, from one direction, how many faces you can see, the opposite direction, you can see the same number of faces. Now, the third direction is from the top to the bottom. Okay, top to bottom, 1, 2, 3, 4. Right, from the top, I can see 4 faces. So likewise, when I look from the bottom, I will also be able to see 4 faces. So 4 plus 4 is equal to 8. So then I just need to add them up and find out the total number of faces. That will be 6 plus 8 plus 8 equal to 22 faces. Now these 22 faces are exposed, so they are painted. Now the next question is, how do I find the number of unpainted faces? Right, so a cube has how many faces? Please let me know in the chat box, right? A cube has how many faces? Right, these are all made of cubes, right? A cube has how many faces? That's right, right? A cube has 6 faces. So when you find out a cube has 6 faces, you can just take the total number of cubes to minus away how many faces are painted. So let's take a look at the total number of cubes. So how many cubes are there in this picture? Right, baby question, very easy. How many cubes are there in this question or in this picture? 1, 2, 3, 4, and one more behind me. So there are actually 5 cubes, right? Not just 4. Remember, there's one hidden underneath the cube on top. So I have 5 cubes. So then, how many unpainted faces there are? We'll just take the total and minus away the painted faces. Okay, so we have 5 cubes in total. Every cube has 6 faces, right? You've been telling me 5 times 6 is 30. Very good. Okay, and now we want to take away the painted faces. There are 22 painted faces, so minus away 22. Then we figure out there are 8 unpainted faces in total, right? There are 8 unpainted faces in total. Right? So when we count painted faces, of course, you can either use touching pairs, right? If I've taught you before, you can use touching pairs, or you can consider the 3 perspectives to figure out the painted and unpainted faces. Now, let's take a look at question 8 itself. The following figure is composed of some small cubes. If it is pasted on the ground and painted in yellow color, how many faces of small cubes will not be colored? Now the question is asking if it is pasted on the ground and how many faces will not be colored. So I paste it, then only I paint. Let's first take a look at how many painted faces there are. Alright, so likewise we have 3 perspectives to look at, right? The first is from the front to the back, right? From the front view, how many cubes, or rather how many faces can you see? From the front, you can see 1, 2, 3, 4, 5, 6, 7. 7 faces that you can see from the front. So likewise, if you look at the structure from the back, there will also be 7 faces as well. So 7 plus 7, 14 painted faces from the front and from the back. Okay? Now, what about sideways, right? Again, if we look from the sides, left and right. Now, clearly, it is more clear to look at the faces from the right. So let's count how many faces you can see from the right. There's 1, 2, 3, 4, right? 4 faces from the right and likewise 4 faces from the left. So there are 8 painted faces on your left and right directions. Now let's take a look at top and bottom. Okay, top and bottom. Now for the top, right, we have 1, 2, 3, 4, 5. 5 faces. Aha! Does that mean I will have 5 faces being painted at the bottom as well? Does that mean I will have 5 painted faces at the bottom as well? I have 5 at the top, so of course there's going to be 5 at the bottom, right? What do you think? Will there be 5 at the bottom? No, there's none, right? Read the question carefully. This is where we see a common thread, right? The question says the structure is pasted on the ground, right? It's pasted on the ground. So if it's pasted on the ground and then you paint it, I will not be able to paint the bottom faces. So the bottom will not be painted, which means in this case, we will only look at how many faces there are from the top. Right, so there are 5 faces painted on the top. So altogether, how many faces are painted? That will be 14 plus 8 plus 5, which is 27 painted faces. All right, and now I want to look at the unpainted faces. So remember, we will use the total minus the unpainted. Now to find out how many faces there are in total, we need to count. How many cubes do you see in the picture? Or rather, how many cubes are there all together in the figure, whether you can see or not? How many cubes are there? Right, so we can look at it column by column, right? There's 1 cube here, 1 cube here, 2 cubes, 3 cubes, 2 cubes, right? So altogether, there are actually 9 cubes. Every cube should have 6 faces altogether, right? So 9 cubes, there will be 9 times 6 faces. But among them, we already know that 27 of them are painted, so minus 27, right? To find out the rest that is unpainted. So altogether, we will get 27 faces that are unpainted, right? So if you want to find painted faces, use the 3 perspectives, right? Front and back, left and right, and the top and the bottom. But if it is pasted on the ground, then of course, right, the bottom, we don't paint it. All right, so that will be it for question 8, right, on 3D coloring problems. Shout out to my NHA students. You should know how to do this, right? I taught this last term. Okay, now moving on, we want to move on to snail climbs well. For my CO kids, you should be very familiar with this topic. Right, let's have a quick revision on what this is about. An ant was climbing upwards from the bottom of a hole that was 20 meters deep, right? So this hole is 20 meters deep. On each day, it climbed up 5 meters, right? However, because at night it needs to sleep, it slides down only 2 meters, okay? So if the ant managed to reach the top just before nightfall, on which day did it climb up on the hole? All right, so when it comes to snail climbs well problem, there is actually one very important thing to notice, right? So let's say, oops, I can't draw a straight line. Okay, let's say this is a straight line, okay, and then you start off, okay, you go up 5 meters, then you go down 2 meters, go up 5 meters, you go down 2 meters, oops, go up 5 meters, go down 2 meters, so on and so forth, right? Then on the last day, right, let's say you start from here and you can go up 5 meters, and then you reach the top, would you fall back down? Of course you won't, right? If I can reach the top already, I will not fall down. I will just escape. So in a snail climbs well question, right, you need to know the last day is special, okay? And another thing to see, why is this a snail climb well problem? Because if you look at the height that the ant is at, it starts at 0, then it plus 5, then it minus 2. Plus 5, then it minus 2. Plus 5, minus 2. Now, if you plus and minus repeatedly, go up and down repeatedly, then it is a snail climb well problem. Okay, and in a snail climb well problem, the last day is special because I don't fall. All right, so that's the point of a snail climb well question. And now let's take a look at how to solve this problem. We already know that the last day is special and the ant manages to climb up on the last day just before nightfall. So what we can do is we exclude the last day because the last day is special. We find out the total height climbed before the last day, right? The total height, including the last day, right? The total height of the hole is 20 meters just before the last day, okay? It climbs how many meters? Now, because on the last day, the ant can just climb for 5 meters straight, so then the total height is 20 minus 5 equals 15 meters. All right, then moving on. I know that I need to reach 15 meters before the last day. But after every whole day, how much can I actually climb up? Is it just 5 meters? No, right? Because every whole day includes the day and the night, right? On the day, I go up 5 meters, but at night, I will fall down for 2 meters. So altogether, right, the net height will be 5 minus 2 equals 3 meters. This includes going up minus the height that it falls down at night. So every day, the net height is 3 meters. All right? The thing is, now that I know every day, every whole day, I climb up 3 meters, how many whole days do I need to go through to the 15-meter mark? Now, every day 3 meters, every day 3 meters. How many 3 meters will make up 15 meters? That will be 15 divided by 3, which is equal to 5 whole days. Okay, and then don't forget, the 5 whole days is just for me to reach the 15-meter mark. Right, this will take me 5 days. But I will need 1 more day to reach the top. So I figure out there are 5 whole days to reach the 15-meter mark. So 5 whole days but I need one more day to reach the top. So altogether, it will be 5 plus 1 equals to 6 days in total. All right, so altogether, 6 days in total. And now, remember, the last day is special. Exclude it first, then do your calculations. Then remember, we need one more day to shoot up to the top. That's the essence of Snail Climbs Well. And with that, let's take a look at question 14 now. Question 14 says there are 28 soldiers crossing a river by boat. There is only one boat, and each time the boat can only carry 4 soldiers, including one soldier who paddles the boat. So each time it can fetches 4 soldiers across, including the driver. But every time after we fetch some soldiers across, one soldier has to return with the boat to fetch the next soldier. So imagine this is the river. On the first time, I can fetch 4 soldiers to cross the river, right? Including one soldier who paddles the boat. But then, right, there are still more soldiers waiting for their turn. So we need to bring the boat back. In order to bring the boat back, okay, this was the boat, this is the boat. In order to bring the boat back, we need one more person to paddle the boat back. And then we fetch 4 people, and then one person have to paddle back. So what do you realize? Right? Every time we cross a river, that is what we call a trip. Right? We cross a river forward or backward, that is one trip each. So the first round trip includes crossing the river and coming back. The first time we cross the river, we bring 4 soldiers across. But then one soldier will need to come back, which means one less soldier has crossed the river after the round trip. Because this one soldier, 4 of them have come here, but one of them will need to bring the boat back. So actually, one less soldier would have crossed the river. Hey, do you notice something? I am plus 4 minus 1, plus 4 minus 1 repeatedly. And if I am doing addition and subtraction repeatedly, it goes up and down repeatedly, then it's actually a snail climbs well problem, right? If I keep on plus 4 minus 1, plus 4 minus 1, similar to the question just now, right? The question of the ant climbing the hole, plus 5 minus 2, plus 5 minus 2. If I keep on plus and minus repeatedly, then it is a snail climbs well problem. And when you remember snail climbs well, you need to remember the last trip is special. Okay, so with that, let's take a look at how to do the calculation. We know that in every round trip, we first send 4 soldiers across, so plus 4. 4 more soldiers have gone across, and then we minus 1 because 1 soldier need to come back. 4 soldiers cross the river, but 1 soldier need to come back. So after every round trip, the net number of soldiers who successfully cross the river, the net number who cross the river will be 4 minus 1 equals to 3. 3 soldiers, right? The net number of soldiers who cross the river is 3 soldiers per round trip. So does that mean, Teacher Yonglam, I know that means it's just 28 divided by 3. Is that the case? No, right? Because on the last trip, we only increase and we never decrease. In this case, right, we don't use day as a unit of time. We use round trip as a unit of time now. Okay, and in particular, in the last trip, okay, let me write down. In the last trip, if everyone crosses the soldiers, if everyone crosses the river, will someone need to come back and put back the boat again? No, because we want all the soldiers to cross the river. So we don't need to bring back the boat. So on the last trip, I only need to send the last 4 soldiers across. I only increase the number of soldiers who cross the river. I do not come back. Now, in that case, how do we solve this question? Remember, step 1, the last trip is special. It only increases. Let's now exclude the last trip. So that will be 28 soldiers in total. Exclude the last 4 soldiers. 24 soldiers will have to cross before the last trip. Okay? Now, in that case, 24 soldiers will have to cross before the last trip. But every round trip, I plus 4 minus 1, which means every round trip, only 3 soldiers can pass the river. So 24 divided by 3. Every round trip, 3 soldiers can cross the river. So 24 divided by 3, I need 8 round trips. Now again, round trips means go across, come back. 8 round trips to send 24 soldiers across the river and bring the boat back for the last 4 soldiers. Now we have 8 round trips, right? Which means how many trips are there among these 8 round trips? Remember, round trip includes 1 trip back, 1 trip forth. So that will be, 1 trip forth, 1 trip back. That will be 8 times 2 trips, right? A round trip includes 2 trips, 1 trip forward, 1 trip backward. So 8 times 2 is the number of trips needed at first. But don't forget, we still have a last trip. This last trip is for the last 4 soldiers to cross the river. So I need to add 1 more trip. And that is why I need 17 trips altogether. Alright, so this is a non-classic snail climbs well problem. Okay, it doesn't include climbing up a well, but whenever you see that it's plus minus repeatedly, you can use this snail climb well method. Of course, you could just keep on do 4 minus 1 plus 4 minus 1 after until you reach your answer. But if the number gets very big, like let's say 2,800 soldiers, then perhaps listing isn't the best way. So try to absorb this method that I taught you just now. Alright, so that is for the snail climb well problem, and let's move on to question 16. Right, question 16 is a calculation problem that includes some special sequences, and I would like to show you these 3 sequences now. The first one is what we call the triangle numbers. Triangle numbers is the sum of a sequence of numbers that starts from 1 and each term increases by 1. So for example, the first picture shows 1 ball, second picture shows 1 plus 2 balls, the third picture shows 1 plus 2 plus 3, the fourth picture shows 1 plus 2 plus 3 plus 4, and likewise, right, what are the next few triangle numbers? Now, these are very commonly seen, okay, and I hope that he could, understand these numbers and try to memorize them. So let's take a look. The first triangle number only includes 1. What's the second triangle number? 1 plus 2 is 3, right? Third triangle number, 1 plus 2 plus 3 is 6. Fourth triangle number, you can just take 6 plus 4, 10. Fifth, 10 plus 5, 15. Sixth, 15 plus 6, 21. Seventh, 21 plus 7, 28. Eighth, 28 plus 8, 36. Ninth, 36 plus 9, 45. 10th, 45 plus 10, 55. Now, these are the first 10 triangle numbers. Of course, it keeps on continuing, but make sure you try to memorize at least these 10. These numbers are very common, okay? And yeah, try your best to familiarize with them. This is the first type of special sequence. The second type is what we call the pyramid numbers, right? You see, these blocks that I show in the screen, they are arranged like a pyramid, not a triangle, but a pyramid, right? It's like a flatter triangle per se, right? In a pyramid shape. Let's try to find out how many blocks are there in each diagram. Now, the first one is 1 block. The second is, we count column by column again, 1 plus 2 plus 1. And that will be, how many blocks is that? Yeah, that's 4 blocks. Okay? And the next one, 1 plus 2 plus 3 plus 2 plus 1, 9 blocks. Okay? And likewise, what's the pattern that you see? Right. Some of you might realize, wait a second, teacher, they look very special in my times table. 1 is actually 1 times 1. 2 is actually, 4 is actually 2 times 2. 9 is 3 times 3. Wait, is that a coincidence? What if I give you a bigger pyramid, right? For example, this pyramid is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. Wow, you see, you are starting from 1, you keep on increasing by 1 to the top, and then you fall back down by 1 back to 1, right? It's like you go up steadily and then you go down steadily. Is there a quicker way to calculate? Does my observation here hold for all pyramid numbers? Actually, they are. Right, so let's take a look at this same pyramid, right? Again, with 6 at the middle column. What if I cut it, right? I cut the right side. So I cut away the 5 and 4 and 3 and 2 and 1. And I paste it over here. So you see, I have 5 plus 4 plus 3 plus 2 plus 1 on the top now. So what does this show? It shows a 6 times 6 grid of tiny little squares, which means there are 36 squares or 36 blocks now. Right. So you will notice that, hey, there is indeed a faster way to calculate the pyramid numbers. The sum of all the terms in a pyramid number is just the highest number multiplied by itself. Right. So if you start from 1, go up, and then go down, right? The sum of all these numbers is the highest number. In this case, 6 times its. All right. So that's the second type of special sequence. The third one is highly related to this shape, right? It's a square number, right? So let's take a look at the square numbers. The first square number, again, very normal. It's 1. Okay, what about the next one? 1 plus how many? I have 1. And now I surround the corner using 3 balls. So 1 plus 3 is 4. The next one, again, I start from 1. 1 plus 3 plus 5 equals 9. You see, I am adding more and more balls surrounding the corner. And just nice, all these numbers are they are all odd numbers, right? You see, the next one, 1 plus 3 plus 5, right, which is here, plus another outer layer surrounding the corner, right? So that's 7. 1 plus 3 plus 5 plus 7 is 16. Right? And if I add one more layer, 1 plus 3 plus 5 plus 7 plus, you see, it's the next odd number. How many balls are there at the outermost layer? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 balls. So that is 25. Right? I have 25 balls. And what do you realize? Hey, teacher, they form a 5 by 5 square, right? 4 by 4 square. That's right. Now the sum is just the number of terms multiplied by itself. If you see 1, 3, 5, 7, etc., etc., and they are all consecutive odd numbers, starting from 1, okay, then the sum is just how many terms there are multiplying by itself, right? Square numbers are pretty similar to your pyramid numbers as well. Okay, so we will use pyramid numbers and square numbers in the next question, right? We want to find the value of the following expression. Now, among the two, of course, the latter bracket is easier to solve, right? What is 1 plus 3 plus 5 plus 7 plus 9? 1 plus 3 plus 5 plus 7 plus 9 is 25, right? I have even shared with you in the previous slide. It is 25. Now, what about the front? You see, the front, even though there's ... even though there's ... it just means I keep repeating the pattern. The pattern is I go up from 1 to 2 to 3, all the way, 1 by 1 by 1, up to 20. 20 is my highest one. And then I fall back down, 1 by 1 by 1 by 1 by 1 by 1 by 1, up to 3. Wait a second, I should include up to 1, right? But here it includes up to 3 only. It's a bit suspicious. How can I calculate this? Now, no worries, right? We just make it more pretty. Okay, we make it into a more standard form. What if I do include, right, from 1 plus 2 plus 3 up to 20, and then I fall back down, up to 3, plus 2 plus 1. What if I include this plus 2 plus 1? Then what is the value of this sum? Right? Yeah, some of you have already given me the answer for 1 up to 20, then down to 3. But if I include this, I start from 1, and that one, the middle number is 20, then this will just be 20 times 20 equals to 400. The sum will just be 400. But now I remove the 2 and the 1. I did not add the 2 and the 1 at the end. That means this sum is not 400. But instead, starting from 400, I need to remove a 2 and then remove a 1. And that will give me the sum here, right? Because there is a missing 2 and a missing 1. If there's something missing, you need to take away the numbers, right? Another case is if something repeats, like for example, if I have another 20 here, it repeats itself. Then you need to add whatever has been repeated, right? Now, in this case, This sum is just 400 minus 2 minus 1, which is 397. And then I will need to do 397 minus 25, right? Minus away whatever is at the back, don't forget. And that will give me 372 as my answer. All right, so it is 372, okay, because many students missed the minus 2 and minus 1. Okay, so I've introduced to you 3 types of special sequence. Be sure to absorb and try to understand, try to remember their characteristics. Okay, and now, seems like everyone is waiting for this question, right? The question with the least accuracy today, which is question 20. An interval and time problems. Oh, what is this question talking about? Now let's read the question. There is a 3-meter long steel tube. So altogether, this tube is 3 meters long. Now, starting from one end of the tube, Daryl first cuts a 30 centimeter long segment and then another 15 cm long segment. He then cuts another 30 centimeter segment and another 15 centimeters. This continues until the whole tube has been cut up. So he keeps on cutting. Given that one cut, let me change the color. One cut requires 8 minutes after one segment is cut. Daryl needs to rest for 3 minutes. So there are 2 places in which time is spent. First, cutting the tube itself takes 8 minutes for each cut, right? Because it's steel, it's sturdy. But then, after cutting, right, Daryl will be very tired. Wow, he needs to rest for 3 minutes before he can proceed to the next cut. The question is asking how many minutes are needed to cut out the whole tube. Alright, so let's try to visualize this with a problem. Whenever you see this type of problem, it cut, or it has a lot of intervals, my advice is to always draw out a picture to show what is happening. So there's a 3-meter long steel tube and Daryl cuts it into some segments. What does the segment look like? The segment looks like a 30 centimeter segment, followed by a 15 centimeter segment. 30, 15, 30, 15, so on and so forth. Right? Do you notice a cyclic pattern? Do you notice a pattern that keeps on repeating? Yes, right. It keeps on going 30 and 15, 30 and 15. So I can actually group them together into a single group. A single group consists of a pair of 30 centimeter segment and 15 centimeter segment. Now, what is 30 and 15? What do they add up to? How long is one group? I have one 30 centimeter segment, one 15 centimeter segment. Right, so altogether, that will be 45 centimeters. Right, so every group is 45 centimeters. I have how long of a tube altogether? 3 meters, right? Oh, it's a different unit, but not to worry. Whenever you see a different unit, just change it to the same unit, right? 1 meter is equal to 100 centimeters. Okay, so then 3 meters is just 300 centimeters. Now we can use 300 to divide by 45. The total is 300. I divide by 45 and I see how many groups of 30 and 15 are there. Right, so I can use 300 divided by 45. Or for the kids who haven't learned how to do multi-digit division, you can just keep on adding 45, 45, 45, 45. How many groups of 45 is enough to make a 300? Right, since this number is small enough, then yeah, sure, you can do that. If the numbers are bigger, please rely on division instead. So how many groups are there? How many groups are there? There are, yes, 6 remainder 30. Whoa, wait a second. Why is there a remainder? Okay, let's identify the meaning of that. 6 here refers to 6 groups. These 6 groups means I have 6 30 centimeters and 6 15 centimeters. 30 means the extra length that I have, right? I can't write this E properly. The extra length that I am left with after cutting away 6 groups of 30 and 15. And just nice, the extra length is 30, meaning that I have one more segment, right? Because remember, the 6 groups is 30, 15, 30, 15, 30, 15. So after 6 times of 30 and 15, right, the next segment should be a 30 centimeter segment as well, right? 30, 15, 30, 15, 30, 15. If I continue like this, the next segment must be 30 centimeters as well. Just nice, this will contribute to one more segment. So altogether, how many segments are there? There are 6 groups. Each group contains a 30 and 15 cm segment. So this will contribute to 6 times 2 segments. But don't forget, I have an extra one more segment here. So that will be 6 times 2 plus 1 equals to 13 segments. I will have 13 segments. Oh, you said 6. Okay, if you use decimal notation, then it's a bit difficult to find out the remainder. How can I further split it into segments? So try to use remainder notation. So altogether, I cut the tube into 13 segments. I have cut the tube into 13 segments. How many cuts do I need to cut into 13 segments? Aha! This is interval problem 1, not even interval problem 2. Okay, the easier type of interval problem. Okay, so if I have a tube, I cut it 1 time, it becomes 2 parts. I cut it three times, then it becomes 4 parts. So to have 13 segments, 13 parts altogether, right? Every time I make 1 cut, you will realize that, oh, the number of cuts is 1 less than the number of segments. Right? I don't need to cut 13 times. Instead, I need to cut 13 minus 1 equals to 12 times. Right? I need to make 12 cuts. I need to cut 12 times. Right. So these 12 cuts is where I will spend my 8 minutes. But don't forget, since I'm looking for the time, other than the cutting time, I also need to spend time resting. Okay, so how many times will I need to rest in this question? I know, teacher Yonglam, every time after I cut, I will need to rest, right? So that must be 12 times of rest. Is that true? Now, let's say you have cut 12 times. You end your job after you have cut 12 times. Now, after the 12th cut, which is the last cut, will you still sit at your workstation and rest for 3 minutes before you say, okay, I'm done? No, right? Your cuts should happen or rather, your rest should happen between cuts. Rest usually happen between the cuts. After you are done with all your cutting, you don't need to rest anymore. Your job is done. Okay, so you just need to think about between the cuts. How many times between are there? Which means you are looking for the intervals between the cuts. That's why I call this a double interval problem. Right, I have 12 cuts. So between them, there is actually 12 minus 1 equals to 11 rests. Right, taking the bottom picture as an example again. Right, I cut 1 time, then I rest. Cut 1 time, then I rest. Cut 1 time, rest. Cut 1 time, then I rest. Cut 1 time, and then I rest. And then I cut 1 time, and then I don't need to rest anymore. My job is done. You see, 5 segments, I need 4 cuts. And to complete these 4 cuts, I only need 3 times of rest in between. Likewise, 13 segments, I will need 12 cuts, right? It's the interval between the segments. And the rest happen between the cuts, so I only need to rest for 11 times. And with that, we can find the total time, right? 12 cuts, each takes up 8 minutes, right? As shown here. Okay, and then 11 times of rest, which takes 3 minutes each. Now, after your calculation, you will realize that it takes 129 minutes. And that is my answer for this problem. Okay, it's pretty difficult because you need to think about 2 levels of objects and intervals, right? Cuts are between your segments, rests are between your cuts, right? That's how you attempt this question. Okay, now with that, let's take a look at the next problem, which is a working backwards problem. Okay, before I continue with the question, right, let's take a look at this warm-up. Pip had some sweets and Bud had 3 sweets. So at first, I don't know how many sweets Pip has, but Bud has 3 sweets. Pip gave half of his sweets to Bud. Now, give half means what? Right? Give half means you divide whatever you have into two parts. You give one part to the other person. You leave another part, the remaining part, to yourself. And these two parts, they are the same. So I am equally splitting whatever I have into two parts. And I give away one part. I keep one part for myself. So this is dividing by 2, right? For example, if I have 10 sweets, I give half, then I will have 10 divided by 2, 5 left, right? Half means I divide by 2. You'll find out what is left. Okay? But the thing is, we drew the train diagram like this. This is divided by 2, right? Does that mean this is multiplied by 2? Right? Because let's say if I don't say give away by half, right? If Pip gives 2 sweets, gives 2 to Bud, then Bud receives 2, right? You see the opposite symbols appear here. But what if it's a give half? Then the opposite of division is multiplication, right? Does that mean Bud will times 2? Pip's amount is divided by 2. Does that mean Bud's amount is multiplied by 2? Do you think this is correct? Can I write times 2 below? Can I write times 2 below? Cannot. Okay? We can't. That's because Pip's half may not be equal to Bud's amount. Right? Say, for example, Pip has 100 sweets at first. Then he gives half to Bud. What is half of 100? 100, the half is 50. So that means he must have given away 50 sweets to Bud and he has 50 sweets left. But if you look at Bud, Bud times 2. 3 times 2, 6. He receives 3 sweets. Pip gives away 50 sweets, but only receives 3 sweets. Does that make sense? That doesn't, right? Whatever Pip gives, Bud will receive, right? But because the half of Pip may not be the same as what Bud has at first, I cannot use times right away. In other words, I cannot say the amount of Bud's sweets has doubled. I can only say it is increased by a certain amount that I don't know. Right? It increases. I just know Bud gets some sweets, but exactly how many sweets Bud gets, I don't know yet. Right? So that's why we need extra information. If Pip has 5 sweets in the end, Pip has 5 at the end. Find the number of sweets he had at first and Bud had in the end. Now, Pip now has 5 sweets. We know that. So then we can find out Pip originally has how many sweets? That will be 5 times 2 equals to 10. Right? 5 times 2 is equal to 10. Now, how many sweets did Pip give away now? Now, let's say this is all the sweets that Pip has. Pip will give away half and he will keep another half for himself, right? Give half means I keep the remaining half. So I will give away half and I keep half for myself. In other words, how much I give and how much I keep, they will be the same. They will be equal. Right? So in other words, he has 5 sweets left, which means he give away, he also give away 5. Right? So 3 plus 5, but has 8 sweets at last. Right? So the moral of the story, whenever you see give half to another person, right? The one person divide by 2 doesn't mean the other person double, right? It doesn't mean that. It depends on the amount both of them have. So with that, let's take a look at question 23 now. Okay, it is a working backwards problem. We have Amy, Bella, Chris, and Debbie having 200 candies in total. First, Amy gave Bella 13 candies. So Amy loses 13 candies, whereas Bella gains 13 candies. Right? So what teacher Yonglam is doing now is he is trying to mark what happens, what's the operation on every person's number after every part of the story. Whenever you see a working backwards problem, right, you need to take note and even write down what are the steps or what are the operations that happen to each and every person, especially when there are a lot of people, because it will be very confusing. All right, Amy gave Bella 13 candies. Then Chris gave Debbie 20 candies. Chris has 20 less. Debbie has 20 more. Then Bella gave Chris half of all her candies. Bella give half. Bella give half means Bella divide by 2, right? She keeps half of it only. So what she has is just half. I divide by 2. Right? Does that mean Chris' number will times 2? Does that mean Chris' number will times 2? Everyone, yes or no? Right? Again, no. One person half doesn't mean the other person double. Right? We only know Chris has some increase, but I don't know how many. So I just note it down first. Okay. Then finally, Debbie gave Amy 24 candies. So Debbie has 24 less. Amy has 24 more. Now they have the same number of candies. That is the ending part. At the end, they have the same number of candies. How many candies did Chris have originally? Okay, so again, we have read the question, we have noted what happens. Let's draw out the train diagram. Okay, so we have 4 characters here, so we need to draw 4 train diagrams, right, to go through what happens to each person sequentially. Okay, now, first of all, Amy gave Bella 13 candies. So Amy loses 13, Bella gains 13, right? But we don't know how much candies they have now because it's not the end yet. Then Chris gives Debbie 20 candies, Chris minus 20, Debbie plus 20. Then Bella gave Chris half of all her candies. Bella's amount is half, but Chris' amount is not double. It's just adding a number that I don't know, right? He just received some. I just don't know how many. Then finally, Debbie gave Amy 24 candies, right? So Debbie minus 24, Amy plus 24. Now they have the same number of candies. Wait a second, do I know how many candies they have at the end? Do I know how many candies they have at the end? Well, here's another point to take note of. These 4 people are distributing how many candies in total? 200 candies, right? They are just giving each other, right? They are not throwing away. They are not getting extra candies. This is what we call internal transfer. I am giving candies to each other within the 4 people, right? So the total doesn't change. So the total is same. In other words, if at the end they have the same number of candies, and at the end we know the total is still the same, so each person will have 200 divided by 4, which is 50 in the end. Right? So each of them will have 50 candies. And now we can work backwards. But do we need to care for what happens to everyone? No, we don't actually need to because we are interested in Chris only. So let's look at Chris. First, Bella gave Chris half of all her candies. So that means Chris received some candies from Bella. How many candies did Chris receive? We have to look at how many candies Bella gave. Right, Bella gave, Chris received. Bella's candy was half and then she has 50. That means at first Bella has 100 candies. Then 100 divided by 2 is 50, right? That means Bella gives away 50 candies, which means Chris receives 50 candies. So it's actually a plus 50. Through the relationship of halving, you know what is the number of candies the other person gets. You have to look at the other person's end. Okay? So then Chris has 0 candies at first. But then Chris doesn't really have 0 candies originally, right? It's at first, it's simply referring to what happens between Bella and Chris. But the real originally happens at the way start of the story and what happened to Chris before he received from Bella. Chris gave Debbie 20 candies. So the amount of candies minus 20 then only becomes 0. That means Chris will have 20 candies originally, right? So my answer is 20, right? Remember, don't just write your answer right away when you see a very plausible number. Make sure you really work through the entire problem, especially in working backwards. If the question is asking originally, make sure you really work towards the far start. All right, so with that, that's the end of working backwards, and we are moving on to something that is more simple, right? The rainbow method. Hey, what is this? This is just a triangle number, right? Can you tell me what's the sum of these 6 numbers right away? 1 plus 2 plus 3 plus 4 plus 5 plus 6 is equal to? That's right, it's equal to 21. Now, other than memorizing the number 21, how else can we calculate it? Actually, we can take one big number and then add one small number. You see, 1 plus 6 is equal to 7. 2 plus 5 is equal to 7. 3 plus 4 is also 7. So we have one big plus one small. Every time I do one big plus one small, the result is 7. How many groups of 7 are there? There are 3 groups of 7 because there are 6 numbers and I pair them up 2 by 2. So there are actually 3 pairs only. And that is how I get 21. Okay? Right. So when I have a series of numbers that keeps on increasing constantly, right? For example, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. There's a constant increase, right? Then we can use the rainbow method. Pair up one big number and one small number. Pair them up. Every pair should give you the same result. So you just count how many pairs are there multiplied by the sum of one pair. Okay, so this is pretty simple. What about this one? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. It's odd number. You see, if I try to pair them up, 1 and 7 is 8. 2 and 6, 8. 3 and 5, 8. There's a 4 in the middle. Right, so I paired one big and one small number. 3 times 8 is equal to 24. And then I add an extra 4, which is the middle term, and that will give me 28. This is when I have an odd number of terms in my sum. Then I still do the same thing. I count how many pairs there are multiplied by the sum of one pair, but then I add up my middle number because the middle number is not getting paired. Now, of course, some of you who have learned very advanced, you would have known that this is an arithmetic sequence, and you can use the arithmetic sequence formula to do this. Okay, now let's have more practices, right? Oh, what if I have 1 plus 2 plus 3 plus plus until 100, right? Would you really count one by one? But don't forget, right, my numbers are increasing constantly. 1, 2, 3, 4, 5, up to 100. So I can pair up the numbers, one big plus one small, right? So for example, 1 plus 100 is equal to 101. 2 plus 99 is equal to 101. Oh, every one big, one small add together is 101. And you see, this looks like a rainbow shape, right? That's why I call this the rainbow method. All right, so then we know that each pair is 101. How many pairs are there? We have 100 numbers. I paired 2 numbers together. So 100 divided by 2, I should have 50 pairs, right? So it is just 101 times 50, which will give me 5050. All right, now let's try again. Okay, what if I'm adding to 50? Again, I can pair up one big number and one small number, and then I have 50 plus 1, 51. One small number, one big number, 51, so on and so forth. Every pair is a 51. How many pairs do I have? I have 50 numbers this time. 50 divided by 2 because I'm grouping 2 by 2. 50 divided by 2 is equal to 25. So I will have 25 pairs. And now I just need to do 51 times 25, which is 1275. Right, is that correct? Is it 1275? Yeah, it's 1275. Okay, good. So 1275, that's my answer. So using this skill, we finally can take a look at number 24, which is a page problem. Wait a second, teacher, this is not related to addition. Well, it is. Right, let's see. a piece of paper was torn off from the middle of the book. Hey, hopefully you have read a book before, right? A book has some papers, and on every piece of paper, there are 2 pages, the front page and the back page, right? So when Cindy added up the remaining page numbers, the sum was 2428, right? And if you take a look at your book, oh, there are some page numbers at the corners, right? Bottom corner of your pages. So what is the smaller page number of the missing page? This question is saying I have a book, there are some page numbers, but I torn off a piece of paper from the middle. And then when I add up the remaining page numbers, the sum was 2428. What is the smaller page number of the missing page? Now let's try to investigate, right? What is so special about page numbers? Now let's say you are reading a book. What is the first page of a book? What is the page number for the first page of a book? It will be 1, and then it will be 2, and then it will be 3, and then it will be 4, so on and so forth, right? They are all consecutive natural numbers. They are all consecutive natural numbers, right? So I torn off one of the page, and the remaining sum is 2428. The problem is I don't even know what page was being torn, right? So I might want to test one by one, but let teacher Yonglam tell you. Whenever you see a question like this, right, a piece of paper was torn, don't worry, right? First, let's just imagine the paper wasn't even torn to begin with. The paper hasn't even been torn to begin with, right? So let's say the book is perfect, right, with no papers being torn. So the sum of the original number of pages must be greater than 2428, right? Because 2428 is what I get after I take away 2 numbers. All right? Then let's try to work out. Okay, so then we need to guess, how many pages does my book originally have? How many pages does my book originally have? Maybe it's 50 pages, right? 1 plus 2 plus 50 will be the page sum if I have 50 pages before I tear off the piece of paper. Now, if you remember, that would just be 51 times 25, which is 1275. But even with 50 pages, my sum is only 1275. Is it possible that after I tear off a paper, the sum is 2428? It's not possible, right? So what does that mean? That means the original number of pages must be larger than 50, right? So maybe you might want to guess, 51, maybe 52, maybe 53, maybe. But when you see the difference is very large, right? From 2000 something to 1000 something, you can risk it and jump a bit bigger. What about 1 plus 2 plus 3 plus up to 60, right? How many pairs are there? What's the sum of each pair? We can use the rainbow method now. 1 plus 60 is equal to 61. So each pair is 61. 61 times 30, that will be equal to 1830. Why 30? Because 60 numbers, 60 divided by 2, 30 pairs. All right, what time we finish the class? After this question. All right, and yeah, after this, you realize that, hey, the page number is still too small. No worries, let's try adding up to 70, right? If I add up to 70, I can pair up one small number and one big number to get 71, right? Each pair is 71. How many pairs are there? 71 times 35, right? Because 70 numbers, 70 divided by 2 is 35. So I have 35 pairs, each pair is a 71. That gives me 2485. And you'll notice, it is already larger than 2428, right? So maybe this is indeed the original number of pages and the page sum originally before I tear off the piece of paper, right? Originally, I have 70 pages. Now, in that case, then we just need to find out what is the sum of the 2 pages that you've torn off. So we can take 2485, which is the sum of pages in a perfect book, minus 2428. And that will give me 57. Now remember, does that mean, my answer is page 57? No, no. Remember, on a piece of paper, there is a front page and the back page. So there are actually 2 page numbers in the piece of paper. There are actually 2 page numbers. And these 2 page numbers, since they are on the same piece of paper, these 2 numbers, they must be consecutive. which means the difference must be 1. So I have torn off a piece of paper. The sum of the 2 pages is 57, right? Because there's a front page and a back page. They are consecutive numbers, so their difference is 1. So we know the sum, we know the difference, we can simply draw the model to solve this problem, right? We have a smaller page number and a larger page number, right? Then we draw the models for them. The sum is 57 and there's a difference of 1. Then we want to find out what's the smaller page number. So what we can do is we can do 57 minus 1 to find out 2 parts and then divide by 2. So 57 minus 1, 56. 56 divided by 2, 28. So we know the smaller page is 28. The larger page is 28 plus 1, which is 29. Right, so altogether, you found out that it is page 28 for the smaller number. Now, of course, you might think, teacher, what if it's 71 pages or 72 pages, right? Now, you will realize if you have 69 pages, then the sum will be too small. If you use 71 pages, so you do 2485 plus 71, you will realize 2485 plus 71 is 2556, right? If you minus away 2428, you will get an even number. Even sum, 2 numbers that are consecutive must be 1 even, 1 odd. The sum cannot be even, so 71 pages is out. And what if there are 72 pages? Now, if that's the case, I think you will also get an even sum as well. And even further than that, the page numbers that are torn off will be too big within the range. So the only possible page number, or rather the only possible total number of pages is 70. All right, and yeah, that's the page problem question. Hopefully, I have managed to solve all of your concerns. Okay, and with that, that is the end of today's live stream. I've gone through 6 questions, but there are still some other questions that I would like to go through, right, including a calendar problem. So I'll share some more, right, in the group chat later. And shortly, right, at 7 p.m., I will be sharing the sample paper tools full solutions as well as a new sample paper 3. And we will meet again at next Tuesday, 5:30 p.m. for sample paper 3's live walkthrough. And that's all for today. Thank you so much for staying for the whole live stream duration. I look forward for your active participation in the upcoming weeks as well. Right. With that, that's the end of the day. I'll see you next week. Goodbye. Okay, goodbye. Bye bye. See you next week.